When you think about solar power, chances are you think of solar panels here on Earth. Yet we've made use of solar panels in space for more than 50 years. The space race was the catalyst needed to drive down the cost of solar technology, enabling terrestrial solar power to develop into a $40 billion industry.
Currently, solar installations on the Earth's surface provide a combined 100 gigawatts of electricity, a small number when compared to non-renewable energy sources. But that number is growing by 30 gigawatts per year, and many nations have announced initiatives to increase the amount of solar power entering their grids. These solar initiatives will drive research and development, improving panel efficiency and output, but there are some inherent limitations to the terrestrial solar model. Solar energy reaching the Earth's surface is diluted by our atmosphere, and our planet's unavoidable day-night cycle is the primary problem. This deficiency is most evident in the evening, during hours of peak demand on the electrical grid. If there was a way to extend daylight hours, this would greatly increase the energy produced. And that can be done. Constellations of lightweight satellites with reflective mirrors may sound like science fiction, but the first steps of that vision were completed over 20 years ago. An experiment in 1992 repurposed a routine cargo delivery to Russia's Mir station to test a solar reflector 20 meters in diameter. For several hours, the night sky had a new spot as bright as a full moon. A new space reflector made of modern components will complete the next phase of this experiment. The mirror, a lightweight aluminized membrane, will be stretched flat by 3 radial spokes telescoping from a central body. Control moment gyros, similar to those used in the International Space Station, are mounted inside the central body of the mirror satellite for attitude control and sunbeam pointing. The 3 spokes collapse, folding the mirror membrane into a compact package, allowing several of these mirror satellites to be carried by a SpaceX Falcon 9 rocket. Once these satellites are deployed to a sun-synchronous dawn-to-dusk orbit, they will deflect sunlight to energy-critical locations on Earth.
For the first time, solar farms here on Earth will see an increase in sunlight intensity in the morning and in the evening. Both solar photovoltaic and solar thermal sites can benefit from longer daylight hours. As more satellites are added to the grid, additional sites will see improved energy production, increasing the viability of terrestrial solar power and launching a new era of renewable energy.